So this is the third problem for conversion of a context-free language to Turing machine. So L is equal to A power n, B power m, C power n plus m. So if you substitute n and m values are equal, the answer is A, B, C, C. Otherwise, A double B means triple C. Double A B means also triple C. Otherwise, double A double B means 4C. So what is the condition means just divide all the string up to C. So before C, after C value, if you count number of A's and B's, those values are always equal to number of C's. So what should we do means first we should replace A as X, then we should replace C as Y. Then again come to A, replace it as X, then go to C, replace it as Y. If you come to left side, A's are replaced with X. Then after that only B symbols are occurred. We should only replace B symbol is also as X, because the sum of A's and B's only equal to the length of C. So we should replace A as X and go to right direction, C as Y, come to left direction. If B occur, once again replace it as X, go to right direction, and if C occur, replace it as Y, move to left direction. So if you replace all A's, B's as X and C's as Y means only X, Y blank spaces are available with an initial state. So if Q not read Y means come to final notation. So this is the main logic behind the Turing machine with this language. So what are all the possible values? So here I am writing the maximum number of A's and B's in it. So this is the input which will be stored in an input tape. I just write it, and the initial state is Q0. So what are the possible values on tape means A, B, C, and we are replacing A as X and also B as X. C means Y. So only these symbols are available. After that blank space are available. So this is the tabularized construction format. So it is step 2, that is transition table construction. Okay. Then we are in initial state. So the control head read the first symbol with an initial state Q0. From our logic, the A symbol is replaced as X and we should move to right direction. So X and we should move to right direction. From our concept, if any symbol is replaced, we should move to new state, that is Q1. So if you go to right side, this is the right side value with the current state Q1. If you are reading A or B symbol, only move to right direction for replacing C as Y. So if Q1 read A or Q1 read B, only move to right direction. So here I am filling the A and B value as it is with the same state. Then if Q1 read C means, according to our problem, the procedure, the C symbol should be replaced as Y. So if Q1 read C, this will be replaced as Y, then come to left direction. If there is any replacement means we should go to new state, that is Q2. So now we shifted to left direction with the new state Q2. Then if Q2 read B or Q2 read A, only move to left direction until the Q2 state should read X. So if Q2 read B or Q2 state read A means only move to left direction. So if Q2 read X means move to right direction with an initial state Q0. The same previous logic procedures are applied here. So if Q0 read A means the second A will be replaced as X, move to Q1 state. Q1 read B means go to right direction. So in one situation Q1 state may also read the symbol Y. So only move to right direction with the same state. So there is a possibility of control head read symbol C with the current state Q1 then the C symbol should be replaced as Y with the new state Q2, and the control head should move to left direction. Now the control head points to the Y symbol with the Q2 state. So for that situation you should only move to left direction. So the control head read Y symbol with Q2 state means only move to left direction. So after that, until X, the Q2 state is there. After that, if Q2 read X means we just move to right direction with Q0. So if Q0 read B means we check the procedure. In a procedure, that B symbol should also be replaced as X. So if Q0 read B means, what is the meaning means? All A's are replaced as X and the equivalent C's are replaced as Y. That is the meaning. So if Q0 read B means this is also replaced as X and only move to right direction with new state. So new state means Q3. So we come to Q3. So this symbol is replaced as X. Then now we are in Q3 state. So if the control head read Q3 with B means only move to right direction. So Q3 read B means right direction. Q3 read Y means right direction. Q3 read Y means right direction. So for reading B and Y value, only move to right direction with the same state. So that is the logic behind this notation. So if Q3 read C means that C symbol should be replaced as Y and move to left direction with the new state Q4. So the now control head read the previous symbol with the current state Q4. So if Q4 read Y, move to left direction. If Q4 read B, move to left direction. So if Q4 read B, left direction. If Q4 read Y, move to left direction. At one situation, Q4 read X means go to right direction with the starting state Q0. So the second B is replaced as X, the second C is replaced as Y, and we come to particular situation. So if Q4 read X means we just move to right direction with an initial state Q0. So if Q0 read Y means the equivalent count of A, B's are replaced as X and its equivalent C values are replaced as Y. That means the processing is completed. So if Q0 read Y means just move to right direction with the same state. After that blank space can occur, then come to final state. So this is the logic behind A power n, B power m, C power n plus m. And the fourth problem is L is equal to 0 power 2n, 1 power n. The strings are 001, otherwise 40 means 11, 60 means 111. So this is the logic behind it. So what is the concept means? The first zero should be replaced. That means double zeros are equivalent to 1. So we should replace two zeros as X and its equivalent 10 as Y. So 20 X means you should go to right direction. If you replace 1 as Y means you come to left direction. So that is the logic. So at a time we should replace, for example, if the condition is like this, at a time we should replace 2 zeros as X and 1 as Y. Then again come to left direction, replace 2 zeros as X and go to right direction and replace 1 as Y. So this is the logic. So we should frame the construction table. So here the possible values are 0, 1 and the replacement symbols are X, Y. Apart from that blank space are available. So this is the situation. And we are in initial state Q0. So once again I draw the possible tape symbols. So this is an infinite tape with a possible string. So initial value is Q0. So the first 0 is replaced as X. Move to right direction with a new state. and the second 0 is also replaced as x with the new state. So at a time, the first two symbols are replaced as x, so we come to new state q2. So if q2 read 0 means only move to right direction for replacing 1 as y. So if q2 read 1 means you should replace it as y, come to left direction with the new state q3. So this is replaced. Now the state is q3. If q3 read 0 means there is no change, only come to left direction. If q3 read x means go to right direction with an initial state for replacing the next immediate two zeros as x. So again these two are replaced as x. So now the situation occurred for q2 state. So if q2 read y means we should only move to right direction. So if q2 read 1, replace it as y with the state q3. So if q3 read y, move to left direction. So for this process, at one situation, double zeros are replaced as x and its equivalent 1 is replaced as y. That means all the replacement process are over. Now the control head points to the y symbol, first y symbol with an initial state q0. That means we should complete the process. So only move to right direction for checking the right side values are filled with only y. So if all right side symbols are y means only blank space will occur immediately. So if blank space occur, come to final state. So this is the transition table. So this is the Turing machine transition table. For this transition table, we should draw a transition diagram. It is already explained in the previous videos. For the transition diagram, just go through it. Thank you.